Lesson 1.4, the distributive property. Distributive property is used in algebra quite a bit. And let me give you the property using variables. It says this: if you have A times the quantity B plus C, what you can do is you can distribute the A to the B and distribute the A to the C. And you would get A times B plus A times C. Conversely, if you have the quantity B plus C times A, it works the same way, but to the left this time. You can do A times B or B times A plus A times C or C times A. Let me give you a numeric example. If I have 3 times the quantity 2 plus 5, I can distribute the 3 times the 2 plus the 3 times the 5. 3 times 2 is 6, plus 3 times 5 is 15, and the sum of 6 and 15 is 21. And that gives us the same exact answer if we just simply use order of operations. In other words, add 2 plus 5 in the parentheses first, then multiply 3 times 7, which is 21. We'll use distributive property to simplify expressions that have variables. We'll also use it when we're dealing with numbers to facilitate mental math, and I'll show you that in a moment. Okay, like terms. Like terms are terms that contain the same variable when the corresponding variable has the same power. So if you have x and x squared, those are not like terms. They have to have the same power. So again, like terms are terms that contain the same variable with corresponding variable having the same power. You will be asked in this lesson to simplify expressions. What that means is that your expression no longer contains any like terms or any parentheses. So in order to simplify an expression, you must first get rid of any parentheses and then combine all like terms. Here's another definition you need to know. Coefficient. The coefficient in a term is the numerical part. The numerical factor of a term is called the coefficient or numerical coefficient. So for example, in the term 6x, the coefficient is 6. In the term y, the coefficient is 1. Every term, every variable term has a numerical coefficient. Okay, let's practice. Here we're going to figure out how we use mental math, distributive property, when performing mental math. Now, I know that you probably already do this in your head, but I want to show you, and you will be writing it out for me to show how you can use distributive property to facilitate mental math. So look at number 1, 304 times 15. Well, I don't know my 304 times tables. So here's how I can facilitate mental math. What I can do is I can break down 304 to an expression that looks like this: 300 plus 4. I can substitute an expression that equals 304, and then that times 15. Now here I will distribute 15 times 300 is 4,500. And 15 times 4 is 60. And I can add that very easily using mental math. So here we will be using these exercises just to show what we do in our heads when we're multiplying numbers that we don't know how to multiply easily. Okay, we can break a number into two numbers that are easy to multiply, and then we can add them at the end. All right, let's look at number 2. 44 times 2.5. Well, what I would do here is I would say, well, 44 times 2 plus a half. I don't know my 2.5 times tables, but I know that I can multiply these numbers pretty easily. So let's distribute. 44 times 2 is 88. That's easy. And half of 44 is 22. Well, that's easy too. And 88 plus 22 is 110. Again, that's using distributive property to facilitate mental math. Okay, 3 and 4 you're going to try on your own. Pause the video, and then I'll work it out as well. Come back when you're done and check your work. Okay, for numbers 3 and 4, check your work and check your answer. Now I know you all know how to multiply these numbers, but I don't simply want you multiplying the numbers. I want you breaking one of them down to facilitate mental math. That's the exercise that we're doing here. Okay, all right, let's continue. All right, here we're going to simplify algebraic expressions using distributive property. When you have algebraic expressions, that means that they contain a variable. And so what we can do here to simplify is use distributive property. So 7 will be distributed to the 3w and to the -5. So 7 times 3w is 21w, and 7 times -5 is -35. And these two are not like terms, so they cannot be combined. Okay, let's do this one. 4, I'm going to distribute it to 6v squared. I'll distribute it to v, and I'll distribute it to -3. So 4 times 6v squared would be 24v squared. 4 times positive v would be positive 4v. And 4 times -3 is -12. So simplified, that expression would be 24v squared plus 4v minus 12. Okay, 3 and 4 on your own. Pause the video now. Okay, please take a look and check your work. So I want you to get used to placing your terms in the right order. So what we do is we will place our terms in order of descending exponents, so from greatest to least exponent, but I don't have anything but 1 as my exponents here, so then on the variables. So then what I do is I order them alphabetically. So normally another way of writing this, and probably a more correct way, would be -18g minus 6r plus 6t. We like the variables in alphabetical order. And then at the end would be a constant. So another way to write this one would be 12m plus 32. It's probably a more correct way to write it. Okay. All right, so now let's look at simplifying and combining like terms. Here we go, number 5. Write this down, 6n minus 4n. Well, we can see that 6n and 4n are like terms because they have the same variable raised to the same exponent. So we're going to combine or add 6n and negative 4n, and so our simplified expression is 2n. Okay? All right, number 6, take a look. 4y cubed plus 2y minus 8y plus 5. So we have y cubed terms, we have y terms, and we have a constant of 5. So if you could just identify which terms are like terms, that makes this way easier. So we have two like terms, positive 2y and negative 8y can be combined, and that's what we'll do. We'll simplify it that way. So bring down 4y cubed, positive 2y combined with negative 8y would be negative 6y, and bring down the positive 5. Please note that 4y cubed and negative 6y cannot be combined because the y's have different exponents. To be like terms, they must have the same exact exponent. Okay, 7 and 8 you will do on your own. Try those on your own, pause the video, and come back and check your work. All right, number 7 is already simplified. Notice that there are no like terms. B squared and 13b are not like terms again because they have different exponents on the variables. So those are not considered like terms. There's really nothing we can do to further simplify number 7. Number 8, we do have like terms, 7a and negative 2a. Those can be combined. 7a and negative 2a combined to 5a. And I brought down plus 4 minus 6a squared. And remember, we are going to rewrite this so that it's in the correct form. We only have a's, but we have an a squared term and an a term. So remember that the exponents on the variables will be in descending order. So we'll rewrite it this way. Negative 6a squared goes first, plus 5a plus 4, and that will be the correct answer. Okay, just a few independent practice. Numbers 3 and 9, you're going to use distributive property on number 3 to facilitate mental math. You will use distributive property on number 9 to simplify. Okay, and here you're going to simplify. So that means use distributive property if necessary and then combine like terms. So you will do number 2, number 6, and number 11. Okay, be ready for tomorrow. We will continue to practice. We will possibly have a quiz. Remember that that's always a possibility. So be ready to understand what I've tried to teach you on this video and to put it into practice. All right, God bless you. Have a great night.